Hello and welcome to the AVOI class. My name is John Maxwell. Today we're going to continue our exploration of inheritance with another worked model. And what you see before you is an animal class that has two instance variables, category and species. Just to update you on the category, those could be mammals, reptiles, insects. There's a number of categories, and inside each of those categories is a species name. So while an animal can contain a lot more characteristics, what we've chosen in this example is category and species. So we have two constructors here, one which is a default constructor, and that leaves the instance variables at their initial states, and another one that takes in two parameters, category and species, and sets the instance variable this dot category equal to the parameter value category and this dot species equal to species, the parameter. This refers to the object itself in memory. It's sort of a self-reflexive keyword, and we've covered it previously. However, in lines 13 through 16, we have our typical getters and setters, accessors and modifiers that get the category and return it, get the species, set the category, and set the species. Lastly, we have a toString which overrides the object method toString, and it represents the animal in a system.out println statement. And likewise, we have the equals method down on line 21, and that also overrides the object class equals method. The object class equals method simply compares memory addresses, not the internal components of an object, to determine whether they occupy the same memory location, in other words, being aliases of each other. That's not the equals method we want. We want, in this animal class, a comparison of category and species. So the toString and equals methods override object class methods that do different things. One, output the memory address, and two, compare memory addresses of two objects. So let's take a look at some of the other classes in our example. We have mammal, which extends animal. It's one category of an animal. An animal, or rather a mammal, has three different forms of reproduction. There are metremes, eggs, those are the platypus and such. The marsupials, kangaroos and such, have like a partially formed birth, and they need a little more time to develop. Placentals is what we, if we were mammals, would be considered. We reproduce inside a placenta. So we have a constructor, and remind yourself that the first call in the constructor has to be the call to the parent class constructor, and we do this using the keyword super. So we send mammal and species over to the animal class and call its constructor using the keyword super. And then we set the parameter value into the class instance variable, again using the this keyword. 10 and 11 are accessor and modifiers, and toString and equals are overwritten, okay, from the parent class. And you can recall the rule, you can overwrite any public method in the parent class to do something different. And in this case, what it does is call the parent class toString method and adds to the end of the string its reproduction quality. And equals compares the um, facets of the parent class and then compares reproduction of this object versus another object. Quick look at reptile. Reptile has classification: turtles, crocodilians, lizards, and snakes, and tuatara, which is ironically a warm-blooded lizard that lives in the south of Argentina. Very small category, but a category unto itself. So, reptiles are classified along these four major groups, and we have a constructor again that calls its parent class constructor using the super keyword and sets the parameter C into classification. We have accessor and mutator methods in 10 and 11, and an overrided toString and equals method, which calls the parent class methods of the same name and adds a comparison in the case of equals along the lines of classification. So we're going to run a class tester, and we'll just take a quick look at what the output is. We create a mammal, and the species is elephant, and the reproduction is among the placentals. We create a reptile, and the species is cobra, and the classification is snake. We print out the category of the first object that we create, one.getCategory. And you can recall that getCategory is a method within the animal class. And one thing to note is that a child of the animal class, in this case a mammal is an animal, okay, can use any of the public methods within the parent class. So there's really no problem with that. The category of one is mammal. It can also, in the case of two.getClassification, call a method in its own class. And so 2 is classified as a snake. Now we can ask, does 1 equal 2? And they don't, okay, because they cannot be compared. But like, which equals method is being called? And it is the method in the animal class, because 2, okay, is an animal, and so is 1. And the equals method in the mammal class does not accept a reptile. We'll take a quick look at that. The equals method in the animal class accepts a mammal for a direct mammal to mammal comparison. So what really is happening is that 1, an animal, dot equals 2, a animal, is actually calling the equals method in the animal class. So that's an example of polymorphism where 1 and 2 are both a mammal, reptile, but also can be considered an animal. One of the great utilities here is that you can put both inside of an array list when the type has been set to animal. And so we have kingdom.add1, and kingdom, once placed in, you can say the animal at index 0 is an elephant. Okay, so that element is a mammal. The compiler knows it and calls the appropriate method getSpecies inside of the animal class. So we keep a hold of that. But want to bring up one pratfall, right? Why is when I add an mammal to the array list and ask it to get production, why is it a problem? Okay, well, the answer is on the line 11, I've declared the array list to contain animals. And when the compiler looks at the animal class, it doesn't find a get reproduction method. Of course, the get reproduction method has been added to the mammal class. So the item at index 0 can't call a get reproduction method because it doesn't exist in the animal class. So what I need to do is tell it that it's a mammal. And so what I'll do is a class cast, okay, still an error, because casting is a lower priority than a method call. So I'll make it cast it first, the object at index 0 to a mammal, and then the compiler knows, oh, look inside the mammal class. So that's an example of static binding. I had to force it to be a mammal, okay, before I could call the mammal class method get reproduction. And so it returns placentals because the animal at index 0 is an elephant and is a placenta. So that's a bit more on inheritance. I'll cut it off here because the other video is longer, more detailed. I recommend looking at that. But if you want the shortened version, this will suffice. Thank you very much. Have a good day.